The speakers today are Tim Shearer. He's an Associate University Librarian for Digital Strategies and IT at the University of North Carolina at Chapel Hill Universities. In this role, he leads the Library Information Technology Division and has responsibility for computing, infrastructure, and user experience, software development, repository development, discovery, digitization, and information security. Tim is interested in how technology can play a transformative role in supporting discovery, delivery, use, and preservation of information. He holds an MSLS from UNC Chapel Hill School of Information and Library Science. We welcome Tim. Next, we have Jason Caston. He's the head of software development at the University of North Carolina at Chapel Hill University Libraries. He leads engineers working on diverse portfolio of projects dedicated to building, maintaining, and innovating the library's digital services, including digital collections and repositories, archival information systems, digital preservation systems, and the public catalog and discovery layer. Thank you, Jason, and we welcome you. Third presenter is Mr. Jeff Campbell. He's the head of infrastructure and management services at UNC, and he leads a team of system administrators responsible for the library's core IT infrastructure. His team ensures the stability, security, and scalability of the systems that support the library services and operations. And we welcome Jeff. Thank you so much for your time today. Take it away, please.
Thank you so much, Anu, for introducing us, and thanks to everybody for having us. Good afternoon, at least that's where it is in North Carolina, where we're speaking to you from. We're going to talk about kind of our experiences with AI bots and how that's affected our servers. The photograph you see is Wilson Library, which is the Special Collections Library on UNC's campus, and that is a real drone. It's a real photograph. We thought it was kind of representative. So this is how it all started. We have a user experience department, and in addition to monitoring our servers, we were getting this message from our user experience folks, which is the website's under heavy load. We're sorry, come back later. And our servers were basically restarting. So next slide. I'll hit y'all with some jargon and a couple of principles, and then we'll move into the actual story where Jeff will take over next. So the first is a distributed denial of service attack. These are deliberate, and the nature of them is that a very large number of individual internet addresses send modest requests to a server, but the number of requests collectively across all those IP addresses is so massive that the server basically can't answer and sort of falls over or stalls out. A second piece of jargon is a web proxy. This may be familiar to many of you, but it's the idea that there's an intermediary between the user and the server. So in this case, Bob provides time. Alice wants to know what time it is, so Alice asks the proxy asks Bob. Bob returns the information to the proxy, who returns it back to Alice. We use this all the time, at least in North America, to do access to licensed resources. For example, we have a proxy that sits on campus. Authenticated users from off campus ask the proxy's on campus asks for the vended resource, and it gets returned to them. Where it gets a little strange is a residential proxy network. So this is pretty much the same as the last slide, but if you see in the middle, it looks like a residence. What happens in this case is that a home or apartment or a dorm or whatever ends up being the proxy sitting between the client and the target server. There's a lot of different reasons why a residence may be in this role. They may have accidentally clicked on something. They may be being paid. But the net result for the target is it looks like the traffic is coming from Comcast or Spectrum or any of the other local providers. The last one I'm going to talk about is search facets. Again, this probably is familiar to most of the folks who are on this call, but we moved in the late 90s from search to wanting to do browse, and browse lets you push into a large data set. and do it through these ideas of facets. So you can see in the top middle, we've got the facet of a resource type, and we've chosen book and a language, Greek. And on the left, you can see some additional facets. We could drill down by location and things like that. What this ends up doing is giving many, 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 many ways to get into a data set, and that's going to be relevant. So our goal is to provide access to information. We're a library. That's what we do. We want people to use our resources. But for years and years and years, there are times when we notice the traffic gets too bad or there's abusive traffic. And so what we want to do is make sure those users are not preventing the regular folks or general users from using our stuff. So we manage traffic and we block abusive traffic. So what's different? Well, you all have to be aware that there's a massive economic and political arms race to see who can climb to the top of the AI world. Here are some of the corporate folks that are trying to figure out who can win the battle. A lot of folks seem to think that the future is AI, and whoever's on top is going to be the most successful. And that has led to some possible public and private partnerships. So we don't have total evidence of this, but there's some evidence, for instance, that DeepSeek has actually got significant ties to the Chinese state. Next slide. So libraries, yeah, a lot of academic libraries are struggling with these crawlers. We're sharing information with a bunch of them, including we have something called the Triangle Research Libraries Network. So this is the Research Triangle in North Carolina, including NC State and Duke. We've worked with Princeton, Indiana, the Science History Institute, UW-Madison, and so on. I am part of several networks. I'm part of a technology network on campus. And when these things began to happen to us, I reached out and nobody else on campus in technology roles were experiencing this kind of traffic. And then I'm part of a libraries network, technology and libraries network. It's national, and almost everybody that responded was getting hammered. I did an informal poll in the spring, and there's another poll out there, and they're similar. This was organic. This was only to the networks I was a part of, so it wasn't a systematic or social science research. But even so, reaching out to my folks, about 20% of the respondents were actually outside of the United States, and about a third were outside of academic libraries. So we're walking this up to discuss memory institutions broadly, and it's a global issue. So memory institutions, we have a lot of unique content, often the only voice in a given special collection, and rich data. We're closely connected to the research enterprise. We have a strong tendency towards openness. We want our stuff to be available to the world. And those faceted interfaces that we talked about are accidental bot traps. And without further ado, I'm going to pass it over to Jeff.
Thanks, Tim. So Tim mentioned an arms race, and what we've been dealing with over the last year and a half really does feel like that. I like to think of it more as an escalating hidden war between Darth Sidious and the evil empire against a ragtag band of rebels, or for you Star Trek fans, a Borg attack against the Federation of Planets. At first, it was straightforward, it seemed. We'd spot some abusive bot activity, we'd block it, we'd move on. But then these crawlers started adapting almost immediately, and every defense we put up, they'd find a way around it, kind of like the Borg. And they did it faster than we expected. This forced us to get more sophisticated, and we had to really come up with a layered defense. And one of the crucial aspects of this Tim hit upon is that we started talking to our colleagues and collaborating with them and seeing that this we were being, everyone was getting hit with these kinds of attacks. And then we brought campus IT into this. And it wasn't just our problem. It was happening across academic libraries everywhere and now public libraries too. Next slide, Jason, thanks. And so when we talk about abusive traffic, how we define it, I guess, is that, we weren't just seeing a few extra hits on our server. We didn't have a high server load for, an hour during the day or peak times like we see during exams or the end of the semester. We were talking about traffic that completely started overwhelming our systems. And it was apparent they were automated attacks that were automated requests that were flooding in that prevented legitimate users from being able to access our systems. If you go back to the second slide that Tim brought up, we're seeing having constant downtime and having constantly to fight this. So think of a single IP hitting the same resource thousands of times, or a bot systematically walking through our digital repository, grabbing all the metadata and images that it could as fast as it could before we had time to respond and before the system crashed. Next slide. And so what we had to start looking for when this escalation treadmill began was the differentiation between real human traffic and bot traffic, right? And it became a challenge to do that. So some of the things patterns we started to identify for machine or scripted activity was just bad actors trying to break into our servers consistently. We'd have bursts of simultaneous or extremely rapid requests, the exact same URL being accessed hundreds or thousands of times over a short period of time, or requests that would follow a perfect methodical path through our website's document tree. Next slide. So this is an example of a bad actor. This is from our logs from earlier this year. So one IP address would hit the same endpoint. In this case, it happened more than 4,400 times in just over 3 hours. So that's about 22 requests per minute nonstop. It completely ignored any error messages that would stop human behavior, right, or a human user. And the user agent string confirmed that this was a scripted attack, not a browser. And if you think about this happening, once, it would be fine, but it was happening thousands of times over, again, a short period of minutes and hours. And it was just a scale that we were surprised that we were dealing with. Next slide, Jason, thanks. And so before the dark times, we would react by blocking, one single IP that might be a bad actor, and we'd block it on the local firewall, and then we'd, push that out to our entire plant. But in May of last year, next slide, Jason, things escalated dramatically. We saw this massive surge of traffic targeting our primary source collection, so our digital repository, our digital collections repository, all of our digital exhibits, and they weren't just random visitors browsing around. They were systematic bots, which were crawling at high speeds, right, as fast as possible, clearly attempting to download as much as they could of these systems. Next slide, Jason. And so as we investigated our logs, we started seeing new names appear. So that slide Tim popped up with all of the AI bots. And so we saw GPT bot, Claude bot, OpenAI image downloader, OAI search bot, right? And kind of surprised us that we were seeing this. We weren't expecting it. And so it was something new versus the traditional crawlers that we did see regularly. And what was most shocking was the scale. We tracked traffic from hundreds of thousands of IP addresses, and one of which was a very large increase in traffic from Tencent. So think TikTok. They're that big Chinese multinational tech conglomerate. And so it quickly became apparent to us that this wasn't some lone bad actor. This was actually an industrial scale coordinated attack, unlike anything we'd seen. Next slide, Jason. And so, our first response drew on traditional approaches to bad traffic. Jason had reached out to his colleagues at NC State and was able to get about 7.5 million IPs that Tencent used. And so we blocked all of those 7.5 million IPs. We also deployed a tool called fail to ban. This is a log watcher that will automatically block suspicious activity that we set the parameters for, and it blocks it in real time. And then we started collecting the blocked IPs from Feldeban and from our other servers, and we would create this global shared IP list, blocked list that we would then deploy. And it felt like progress at the time, but we quickly realized, you can go to the next slide, Jason, that we were just plugging holes in a sinking ship. And then late November, this happened, right? Things shifted. And suddenly one day we started seeing traffic hit our catalog. And so this is a representation of late November where things are humming along, system processes are normal, and then bam, we have this incredible spike out of nowhere that brings our catalog down. The next slide, Jason. So like I said, it shifted. Things started moving from collecting data from our primary full text resources to hitting our discovery layer. And the traffic source was different. Tim alluded to that. We were seeing big data. We weren't seeing big data centers anymore. We were seeing residential proxies. So IPs from Spectrum and Comcast and Verizon. And so we realized we were dealing with a residential proxy network, essentially a rented botnet using millions of real household internet connections. Again, whether they knew about it or not, it doesn't really matter. It was just happening. And we also realized that these searches against the catalog weren't human, but machine generated. And we knew this because the search string included a large number of facets, nearly impossible for a human to create through our search interface. And we also know that the searches included odd subject lines. So one of the examples Jason's going to talk about in a little bit is Finnish music. We have a very small collection of Finnish music, I think maybe 18 items. And we were seeing these continual searches against Finnish music. And at that point, we realized that IP blocking became kind of useless. Next slide. And so, our response, we tuned the catalog, we added more resources to keep it running. The bots consume the resources. So we would respond, it would adapt. We created new rules in Feldeban to block any IP making 8 or more faceted searches. That was, I think, one of the most ingenious things that we came up with to use Feldeban in that way. So 8 or more facets that no real person would do, but the bots adapted almost instantly. We adapted Feldeban to block the subnets, and the bots got switched to entirely new subnets. And eventually we saw traffic from multiple countries, China, the US first, then China, Brazil, and it just continually kept jumping to different countries when we would respond. It's kind of like global whack-a-mole, right? And so again, we realized that static rules will never keep pace with a constantly evolving adversary, and that we needed to come up with a different approach. And so we kind of took this multi-layer approach to doing that. And the first is this traditional IP blocking. In May of this year, we refreshed our entire Feldeban role, where we re-implemented user agent lists for known bots as a series of lists based upon categories. These categories come from dark visitors. There's a link there in the slide. So we now block all bots in the following categories, in categories, and some of them include AI data scrapers, search crawlers, etc. And we consolidated enabling of static blocks and Feldeban across our entire plant instead of just host by host. And so now things are applied more consistently across all of our public web servers. And we just started trying, searching the logs and trying to come up with new Feldeban gels that we could create, trying to catch malicious agents that didn't self-identify as bots by user agent. This had mixed results. Most of them didn't work right because it is really difficult to distinguish legitimate and illegitimate traffic. Eventually, we disabled most of them. One remained, and that was basically banning clusters of requests producing 400 series status codes. And finally, we had to increase our resources across our hosts to keep up with good bots. Googlebot, Bingbot, when they do hit our sites, we do see a heavy spike in traffic. And so we had to increase resources so that the hosts would be able to handle that. So that's the first layer, and Jason's going to take it away and continue the discussion.
Thanks, Jeff. So I'm going to walk through some of the different layers of our approach, including some things that we tried and maybe haven't followed through on just yet. So starting now with the second layer. So the first layer was, essentially taking what we had been doing and extending that as far as we can, adding dynamic aspects to it, and doing a lot of attempted bot detection. And layer two is basically screaming for help. We were feeling desperate. We were having trouble keeping our catalog online. It was going on for weeks. We reached out to our regional colleagues and some colleagues across the country to see if other people were experiencing this. We also reached out to our campus IT security and networking department. And so what was interesting was that for some reason, even among libraries, we were a bit early on the impact scale and a bit severe. But everyone seems to, or nearly everyone seems to have been impacted by now. And so for whatever reason, our catalog specifically was severely impacted starting in November. When we reached out to our campus IT security and networking folks, they had not seen this yet, and they were not aware of it, and they hadn't received any reports of it across campus. But they did kind of affirm our concern by confirming that it was incident worthy. And we came in with sort of like this ambivalent attitude about whether we should call it a denial of service attack, because it seemed to lack the intent of a denial of service attack, where rather than specifically attempting to take our servers down, they were just harvesting our data with such irresponsible aggression that they didn't seem to care whether our servers went down or not. But the mechanism was essentially the same. It was extremely distributed, very evasive, And so one of our IT security colleagues said that from his point of view, authorial intent is irrelevant, meaning that like intent is one thing, but the effect is the other. And it looks, basically, it looks like a denial of service. It acts like a denial of service. It's denying service. We can think of it that way. They then went and reached out to national colleagues in security and networking and found that they were hearing from their libraries as well that they were starting to experience these sorts of issues. So we started marshaled a team to help us work on this. Next, because we were really initially mostly experiencing this just with our catalog, and that changed later. We've experienced it across our entire portfolio almost. We really dug into application and server optimization, particularly before we really understood what was happening. And so we did like kind of memory and processor profiling. We did, performance assessments of the applications, went and made some targeted optimizations through resources at the servers, increasing memory, CPU, these sorts of things. Revisited our server, like our application server configurations to see if they were still optimized for our resources, see if we were using best practices there. And we removed some features that we saw were getting hit pretty hard and we considered to be kind of optional. And one example of that is kind of sending yourself a text message of the catalog record through the catalog interface. And we worked in collaboration with our UX department on all of that. So the initial result is that it did provide some temporary relief. It basically raises the ceiling. But the ceiling is still there and the core problem is still there. It doesn't really do anything about that. It just delays the point at which we suffer from it. We probably should have done this anyways. We had some performance improvement in our application. And so that was a good lesson. And we're trying to incorporate more of this now in our general kind of maintenance practice. But it, bought us a little time, but not much. And so then I'm going to revisit this idea of blocking anomalous requests that Jeff introduced. We were really tearing our hair out. We were running out of ideas. Everything we had ever tried to do in the past that had worked, like, didn't really seem to be doing anything. And so I started like just watching the logs, the web logs, just like literally watching them go by. And I started to notice some patterns just watching, which is that there were a lot of the same types of searches, very similar searches happening, and they tended to be really on esoteric topics. So on this day that I started doing this, December 4th, 2024, it happened to be Finnish music, which we have almost nothing related to that in our collection, very, very small amount of content. In all of November, when we were receiving bot traffic, we received 15 searches for the terms Finnish in music in our catalog for the whole month. And on December 4th alone, we received 11,329. And Finnish music is nothing special about Finnish music, but it's basically where they were in the alphabet or where they were in the facet list at that given time. And what it emphasized is that we had basically accidentally built a bot trap. There later were articles about this in Wired and stuff like this about some genius who builds a bot trap. And I'm like, we did it already. Our whole field did it. There's so many facets that you can take one particular facet and then figure out which other facets you can combine with it, and then which other facets. And it's this, practically almost infinite set of combinations that can be produced. And it introduced this sort of strange realization about these bots, which was that in terms of evasion, they were extremely sophisticated, like nothing we had ever seen before. They would, if we would ban an entire country, they would switch to another country, this kind of stuff. They would use domestic internet providers. They would come from smart devices or whatever, super, super sophisticated. But in terms of actual crawling, they were very crude. They had no kind of breaks, right? So they were not getting new content here. They were just going through and brute forcing this, right? So it seemed like a crawler that was developed rapidly, but perhaps with access to major infrastructure for doing distributed requests across the internet. So we also started noticing these strange patterns with the numbers of facets being applied. And so in November 2024, where we already had bot traffic, we received almost 300,000 requests with 15 or more facets. And it's a very unusual search in a catalog. It can be hard to do even on purpose. And on December 4th alone, we received 140,000 of those requests, so almost half of all of November's, which was already high. And then we started getting into 20 or more facets, which is very, very unusual. And you can go to any catalog, go to your home institution's catalog and try to get 20 facets applied. That's 17,527 of those, and even 203 with over 25 facets, which is crazy. And in general, on December 4th, we received 648,000 requests from 22,000 distinct IP addresses. So we got into this, we felt like we had a toehold here in this idea of finding new ways to block anomalous requests. So we developed a fail to ban filter to ban IPs making requests with excessive numbers of facets. And we started to think now, try to kind of take lemons and make lemonade. We started to think of our catalog as kind of a honeypot. Like maybe this, because of the nature of the facets, maybe we could use this as a way to detect traffic that's unlikely to be human, create ban lists from that, and distribute that to our other servers. So we worked with UX colleagues and our catalog committee to define the facet limit. We came up with a range of 8 to 12 facets as a bannable or a blockable limit. And different institutions are going to have different opinions on this. And we've kind of moved the number up and down based on how hard we're being hit. We initially set it to a 2-minute ban, but later increased it to 12 hours for the first offense because of how heavily we were being hit. So within the first 48 hours, we banned 16,000 IP addresses. The weekly request volume was reduced by 81% from 3.6 million to 673,000. And most importantly, we received 0 user complaints, which is wild to me. We blocked 16,000 IPs that are doing searches in our catalog, and there were no complaints. So the outcome was 1 month of blissful overconfidence. We shared our practice, shared this mechanism far and wide, but the bots eventually evolved to use fewer facets, and they started figuring out the limit and using an even larger pool of IPs that could overwhelm our bans. This filter is still in place, though, because when we did remove it, we started seeing renewed high facet traffic, and we started having outages again. Only one user in the first almost 10 months now has reported a legitimate query being blocked, and we've since increased the facet ban limit a little bit and haven't received any more complaints. So the fifth layer here is the web application firewall. So we partnered with our campus networking and also security folks, but particularly networking, to work with a vendor they had a relationship with to deploy a commercial cloud-based web application firewall in January. So this is shortly after the previous technique in December kind of ran out of steam. And so a web application firewall is basically a proxy that sits between web users and servers. So every request to the catalog would first go through this commercial cloud-based server and then be forwarded on to us and passed back. And at that point of the proxy, there's all kinds of analysis that can happen to try to detect, is this a bot? Is this a known bad IP? Should we rate limit it, et cetera, et cetera. The built-in bot filtering from the vendor, which is based on a kind of proprietary idea of client trustworthiness, did provide immediate relief. And the vendors, we ended up working with some pretty senior engineers with the vendor because we were having trouble with our initial reps and really addressing this issue. And they had to apologize for the smiles on their face because it was just such an interesting problem that they hadn't seen before. So the outcome was that we got another month of blissful overconfidence. The bots eventually adapted and found ways to partly overcome the firewall protections. It was still effective at debulking traffic. So even if we are accurately banning traffic, we still have to handle all those requests. And when you're talking about millions of requests per day, it can be a lot. And so it was, and it still is, removing a good chunk of just bot traffic, but just not enough. It also provides load balancing and rate limiting features that we probably could make better use of. And we're still determining our long-term plan in terms of the role of a web application firewall in our portfolio. Layer 6 is one that we ended up not pursuing. It's the vendor's premium AI-driven bot detection. It was fairly effective at limiting bot traffic over the few weeks that we tried it out, but it was prohibitively expensive. It more than doubled the already fairly high cost of the web application firewall. And at the same time, we had started implementing Cloudflare Turnstile, which was also effective. So between those two things, we decided to move on without it. So coming to Cloudflare Turnstile, which is, I would argue, is the most effective part of this multi-layered approach, but is not sufficient on its own for us. We were kind of learned about this through a blog post by Jonathan Roshkin, who is very active in the Code4Lib bot Slack channel, about his work implementing Turnstile and library systems and Rails Blacklight-based systems. So Turnstile, it's basically like a CAPTCHA type system, which our staff were horrified to learn about, and everyone was begging us not to use a CAPTCHA, and we didn't want to use it either. But we found that this actually was a lot less disruptive than what we're kind of mostly familiar with. It operates automatically for most users, and you've surely seen it on the web where it's a little rectangle with a little spinny thing, and sometimes it gives you a checkbox to check. And it operates through a combination of fingerprinting, behavioral analysis, lightweight challenges, and a lot of other cool techniques. We targeted resource-intensive endpoints, such as search and some large downloads. And we found it to be very, very effective. Most importantly, maybe it's free. It does block good bots, which is a problem, and I'll talk more about that later. And we've received very few user complaints. So we've now implemented this on many of our web-based services, almost all of them, at least in some parts. We still have some difficulty with major bot surges because we haven't implemented it universally in order to preserve access for good bots to a lot of our website. But there's no evidence of bots directly bypassing turnstile right now. So all of this was done with an eye toward user experience, accessibility, and security to the best that we could in the time allotted. And we worked closely with our user experience group on all of this. We moved quickly, but we provided user feedback forms anytime we were blocking. And we set it up so that it could be linked to the app in the blocking method. Turnstile is WCAG AA compliant with an extensive privacy policy, but it does use the identified aggregate data. Our firewall vendor is GDPR compliant, and most importantly, in terms of user studies and things like that, although we would like to continue to pursue those, offline catalogs are really bad UX, so we had to first deal with that. So limitations, there are a lot. There's a big concern about false positives, right? People being flagged as being a bot and blocked from our services. We're currently receiving roughly 2 to 3 reports per month. Most of those have been fairly easy to resolve. They're often a result of using, often without realizing it, a commercial VPN that gets flagged because it may also be being used for more malicious traffic. And the primary example here being Apple's private relay service. Another issue is that blocking good crawlers, like Google, can have negative consequences. So we tried to block on our institutional repository not block, but put a turnstile in front of all pages. And then we got an email from Google saying, we're not able to index your stuff in Google Scholar. And so we had to scale that way back. If we put it in front of our finding aids wouldn't be indexed by Google, and that would be a big problem. But on a site like the catalog, where we feel like SEO is less essential, we can block a bit more widely. But even those good crawlers are now a problem. They used to be very well behaved, but now we get crawlers from Google and other self-identified vendors that are extremely aggressive all on their own. And so we've had to come up with ways of managing that. It's quite tricky. We need backdoors for legitimate non-human users because our own bots, our own non-human users, basically can't get through these turnstiles and can't get through sometimes the web application firewall. So this is stuff like we have an embedded catalog search on our library's website, and it uses kind of API interactions between the servers that couldn't bypass turnstile. Web application firewalls can degrade network performance and create a bottleneck for all services, and because basically everything's passing through another server now. And I think this is something I really want to emphasize. We aren't necessarily against automated or even LLM use of our resources, but we need to keep those services online for humans first. So going forward, we're continuing to implement evolving best practices on all servers. That includes turnstile, IP blocks, widespread IP blocks, optimized web server configurations, application performance auditing, et cetera, these fail to ban rules. And configuration is ongoing with even daily changes, even now. Other promising solutions I want to kind of shout out. One is Anubis, which is a really fascinating project that the developer of which has now started joining some conversations within libraries about these problems. It's essentially kind of an open source self-hosted version of Turnstile, and that's probably not fair at all, but it serves a similar purpose where it checks the traffic and it uses a variety of mechanisms to try to determine if it's a bot. There are other web application firewall vendors. One I'm really, really curious about is that Cloudflare has deployed, or it's like launched a pay to crawl service where you can require a crawler to self-identify and pay a certain fee to be able to crawl your site. And I wonder if we could use that with like a $0 fee just to require crawlers to identify themselves before they try to crawl our sites and to give us the ability to rate limit them. Information sharing among libraries is critical, but especially when something is changing so quickly like this. And another thing we've considered and we almost started doing out of desperation is prioritizing different service tiers based on institutional IP address space, geographic regions, things like that. But truthfully, we hate this. It feels like totally the wrong thing to do. But if we have no other options, then it's a tool in the toolbox. So lessons learned in future directions. AI is really challenging the open web. And by now, probably most of you have read articles about this. But if you haven't, you've probably at least noticed a lot more paywalls, a lot more bot checks for pretty much everything. So this whole idea that the libraries, I think, are really at the center of kind of totally free and open access to information is being challenged by this. And I've seen major academic libraries in the United States blocking access to their catalogs, requiring logins, this sort of thing. Are we more of a target than we used to be? So as a field, we always follow good security and performance practices, but at the same time, we do often assume that we're not really a high value target for the most sophisticated attackers. And this may no longer be a reasonable assumption. So do we need to become less open with our solutions or more guarded at least? And what does this mean for stats? Stats are going to be a nightmare during this time. If you're getting literally like 10 or 20 times the normal traffic from clients that cannot be easily or identified as bots, how are we going to filter them out? What does this do to our numbers? Does it even make sense to try? So defense requires multiple layers to kind of bring it all together. By far, the most successful has been Turnstile or Anubis or these other services. But we're also detecting and banning behavior unlikely to be human, optimizing our servers, throwing resources at it, trying to block clients based on various signatures, using firewalls, IP blocks, rate limiting good bots, prioritizing campus traffic. And it really takes a village, and there's so many people that have helped us with all of this. And I want to give a particular shout out to David Romani, who would be here presenting with us today if he hadn't selfishly decided to retire. But he was critical to a lot of this work, and we miss him very much. Is it still a problem? Is this old news? We were practicing this presentation just the other day, and we ended up having to spend a good chunk of our meeting dealing with the fact that the catalog was going down again over the weekend. And we had this huge surge of traffic, and we had to make changes to how we were implementing Turnstile to implement it more broadly to deal with this. So yes, it is still an issue. And some resources here. The best resource will be our Code for Loop journal article, which should be out any day with a lot of citations. But here are some references to a couple of groups at Lyrasis, the Code for Loop Slack channel, which is very active, and two studies in this space from the Engelberg Center on Innovation, Law, and Policy, and a core survey. Thank you so much. Do you have any questions?
There's several questions in the Q&A section, if you would.
Let me pull that up.
Thank you.
So are any of our targeted systems vendor hosted? If so, are the vendors working with us to stop these attacks? I don't think they are right now, but I do wonder about this. And this is something that a lot of people have asked me, which is that like, so if we use a vendor hosted system, are we just out of luck? And it's like, that's one possibility. The other possibility is that the vendor, especially if it's a larger vendor, has an incentive to implement kind of maybe expensive and sophisticated technologies to manage this. So it might be that it just works. I'm really not sure.
I'll just speak up and say I don't want to speak with authority, but I have gotten hints that I think are real that vendors are also getting hit with this stuff. They're just being somewhat more cagey about it.
I can speak with some examples. So I serve on the Innovative Users Group, which is affiliated with Clarivate's innovative Sierra product, and a lot of I know they've been getting hit, and they've responded to that, as well as started working with a lot of self-hosted clients to ensure that the system can be, have some checks and balances put into the system. They've worked with a few places like the I'm going to say it wrong. It's either Prouder or Powder Public Library in Colorado. Their self-hosted site. They've worked with them to actually implement Feldaban. So they're responding to their systems and then working with customers who are self-hosted as well. I did reach out to Atlas, which is a vendor we used for hosting Iliad, Aeon, and Ares. If any of you use those tools, just to ask what they were doing, if they were seeing any activity like this. And as Tim said, they were kind of cagey about it, but they did admit that they have been seeing activity and that they were implementing, uh, fail safes to ensure that systems weren't going down and we weren't losing access. And so far, we've not seen anything, any of our self-hosted sites. And I can only imagine we're cloud hosted with Jira, Atlassian's product, and I'm sure they've been hit as well by these, but I don't have any information related to that.
Is your impression that bots are harvesting in categories by subject and type? Do you think they tag the gathered data with these facets and use the metadata information for AI model training? Or do you get the sense that they go through in this faceted manner as a way of mathematically ensuring they crawl everything? I think it's the latter. I think I haven't seen I have no idea what they're doing with the data. It would be cool, honestly, if they were that smart. But my sense from watching the traffic is that it's really just link following, just brute force link following.
Maybe there's an opportunity for a librarian out there to contract with
right.
a company to categorize their
There
crawling
were,
activity.
yeah. There were a lot of jokes going around in the Code for Lib Slack channel about how, like, if these bots are really as smart as they say they were, we would love to negotiate with them and provide the data in a full set for download and ask them to lay off of our servers. But that doesn't seem to be possible right now. And a little shout out to Jeff. You see this, Jeff? You helped someone's library back in March. Thank you for.
Yeah, I don't see it, but you're welcome, whoever it was.
Victor Zuniga. Follow-up question. Do you think libraries can ask library system vendors to help block this harmful bot traffic? Potentially. What do you think, Jeff? This is more your area than mine.
I was looking for whoever gave me the.
Do you think libraries can ask library systems vendors like Ex Libris to help block this harmful traffic?
Yeah, I certainly think so. I think they have an obligation to do that. And again, just speaking from the innovative side of things, during our conference in March, I talked about what was happening here, and Innovative responded, and they actually, on their own, because they were, like I said, they were seeing their hosted sites being hit. And they responded to me directly. We were kind of like a first test of some of the things they were trying to implement configuration wise on their servers. And then, so yeah, I think we should, and they are obligated, I feel, to make that happen.
Then a similar question about what lessons learned could be shared back. Honestly, I think after having some recent conversations with folks at Cloudflare, I think if someone was just trying to throw some money at the problem and solve it quickly, the best solution is just to use Cloudflare as a web application firewall, which would include turnstile usage at the network level. And they seem to be positioning themselves that way. But I suspect that a lot of these vendors are using major consulting firms or firms like Cloudflare to solve this rather than in-housing the expertise, but I don't know. And share an estimation of how much money you've spent over the past year implementing the tools. So we think how to mitigate at my library. It would be really helpful to know a ballpark. I'm assuming we're not going to count salary money here because that would blow it up a little bit.
Well, I actually think that's important to note that there was the better part of 3 months where 2 to 5 people were working on this anywhere from 10 to 50% of their time, sometimes all day. We were on a call till I think it was 10 o'clock on a Friday. So I don't want to minimize the staff time. Go ahead, Jason. Sorry.
No, but in terms of money that we've spent, most of what we've implemented has not cost money. There is our web application firewall. I don't know if we're comfortable are we comfortable giving numbers there, Tim?
I'll just say it was around 20 grand a year to do the web application firewall that we were looking at, and to add the bot tool was way more than twice that, which is what we decided not to do. We think there are more cost-effective tools out there, and we're exploring some of those now.
Right. I've talked to a couple of vendors recently, and I think probably covering the full portfolio for an institution like ours would, probably run in the $30,000 to $50,000 per year range. Seeing
I
good
should
examples.
say that, well, I'm sorry to interject, but I mean, we were able to talk about 6 different layers that we could do. I feel extremely fortunate to work at UNC Chapel Hill and work with colleagues like Jeff and Jason and David, who was already discussed as another resource. But not everyone has the resources we have, either financially or in terms of staffing or access. We have access to the servers, to the network, to the application, and to the interface. So it's really important, I think, to figure out which things you can do in your world. And Jason's mentioned several times that putting something in the interface seems to be fairly cost effective. And that's why you're hearing a lot of Turnstile and Anubis solutions. Sorry, I didn't mean,
No, that's great. Have we seen good examples of vendors incorporating tools like fail2ban or web application firewalls in their ILS offering so libraries don't have to bolt these on after the fact? Jeff, have you heard anything about this?
Yeah, I think it goes back to what Jason said earlier, that, we just have no way of knowing what they may or may not be doing. But I certainly think it's, again, feasible to reach out to your sales rep or, technical contact at these vendors and ask what they're doing. I mean, you're paying them lots of money in order for them to host your site, and they have a responsibility to you. And I suspect, because of good practice, most of them are doing something related to that. They have to be. So.
And then, have we seen the bots be able to access content requiring authentication, or is it purely discovery layer search results? So yeah, I haven't heard of any examples of bots cracking through authentication. I do think that it will probably, although that's true, I think they may prove to be savvy at finding information kind of leakages, right? So if you have a JSON API that includes a bit more metadata than you really should, they may find that, right? But we don't have any examples of them actually getting directly through authentication.
I'll jump online and just confirm that it is our intent to share the slide decks, and that's part of the reason that we've got hot links in the resource slide, just in case it's useful for y'all to know that. I'm also just going to take a second to shout out the Lyrasis hosted solutions showcase. So this is an attempt by the community to get together and do kind of what we're doing here, but they're use cases. So if you attend them, you might see yourself in one of the use cases and find a solution. And the 2 upcoming ones, I think one's from Stanford and one's about Anubis. So you could tune into those. I'll also say that there's some talk in the community about us being open with open source and talking about our solutions, but that in fact, bad actors can look at your open source and or watch what you're doing and then react accordingly. So there's some thought being given to how open we should be being about our solutions. Just throwing that out there.
Thank you, Jeff and Jason and Tim. We really appreciate this presentation and you taking the time to share your knowledge with us. And thank you.
You're welcome.
Thanks,
Thank you.
everyone. Yeah, appreciate it.